Hello everyone. In this question, we are given a cross-section and we are asked to calculate the axial load and moment for the cross-section shown above. So we have three different drawings. The first one, part A, is showing the cross-section where there is two sets of longitudinal steel, AS1 and AS2, and we are given the information that both have the same area, which is equal to 600 millimeters square. The clear cover depths are 35 millimeters for both sets of longitudinal steel, and the height is 500 millimeters and the base width is 300 millimeters for the cross section shown. In the question, the natural depth, which is C, which is the distance between the uppermost fiber to the neutral axis, is equal to 109 millimeters. So actual figure B is showing the strain distribution in the cross section. So the concrete's strain in the uppermost fiber is equal to 0.003 given in the question, and we are required to calculate the strain in the steel layer 1 and the strain in the steel layer 2. We are going to use the similarity between the triangles to calculate the strain values in that steel layers, and we will compare this value with the yield strain of this steel in order to get the information if those steel layers have yielded or not, which will affect our calculation in getting the result for the force and the moments. And the third figure is showing actually the internal force distribution. When you just think about that distribution as same with the strain distribution, you can see that our steel layers FS1 and FS2 have opposite directions for the forces, because FS1 will be affecting here and FS2 will be acting and on to the side. And the concrete will also have the same direction with the second steel layer forces. The depth of the concrete layer will be equal to K1C, and in this case K1 will be 0.85 unless otherwise stated, and we know the C, which is a neutral depth, and it is given as 109 millimeters in this question. So as the first step, we need to calculate the yield strain of the steel using the simple formula as here, which is expressed as ESY, which is the yield strain of the steel, which is equal to F yield divided by the modulus of elasticity of steel. So one thing we need to know, modulus of elasticity of the steel that we are using in these questions will be equal to 200,000 megapascals. So I'm writing 200,000 megapascals here, and the F5, which was given in the question, was 420 megapascals. Let me put it at the top, and when we calculate that using that equation, we get the strain value is 0.0021. So if the strain values in the steel layers given here are greater than that value or equal to that, this means the steel layer has yielded. If it is less than that, this implies the steel layer has not yielded yet. So let's go and use the triangle similarity to get the strain values in the ES1 and the ES2 respectively. So starting with the first ones, let's start with the ES1. So we know that this distance is 35 millimeters, and let's use the similarity between the triangles and use that the ratio of 0.003 to 109 is equal to ES1, and with the ratio of this distance, which is equal to 500 minus 109 minus 35, as you can see here. So let's express this as like this. 0.003 divided by 109 equals to ES1 divided by 500 minus 109 minus 35, and we get the ES1 as 0.0098, sorry, this 0.00980, which is greater than 0.0021. So this means that first steel layer has yielded. Let's use the same similarity for getting the ES2, and we will use such the equation like 0.003 divided by 109 and ES2 divided by 109 minus 35, because this distance again is equal to 35 millimeters. So let's write it here. 0.003 divided by 109 ES2 divided by 109 minus 35. We get the ES2 as 0.00204, which is less than the yield strain of the steel, which is 0.021. So this means second steel layer has not yielded. Second steel layer